this video we are going to discuss about the Mosfets. So you can see about the drain and transfer characteristics, current equations, pinch of voltage and their significance, threshold voltage and small characteristics. So first you can see about what is metal oxide semiconductor. So Mosfet stands for metal oxide silicon field effect transistor or metal oxide semiconductor field effect transistor. So this is also called as IGFET, which is known as insulated gate field effect transistor. This FET can be operated in both depletion as well as enhancement modes of operation. So you can see the depletion mode diagram and the enhanced mode diagram. So this N channel MOSFETs are similarly known as NMOS. In construction of the N-channel MOSFET, it is lightly doped and this P substrate is consist of two heavily doped N-type regions which acts as the source and the drain. Between these two N plus regions, there occurs the diffusion to form the N-channel which is connecting both the drain as well as the source. And here a silicon dioxide, that is SiO2, acts as an insulator which is present in the entire surface, and the holes are made to draw the ohmic contacts between the drain and the source terminals, since this SiO2 is present in between it. And the conducting layer of aluminum is also placed over the entire channel. Upon this insulator layer from source to drain, which acts as the gate. This SiO2 substrate is connected to the common or ground terminals. Because of this construction, the MOSFET has very less chip area than BJT, that is 5% of the occupancy when compared to the BJT. These devices can be operated in the modes, that is enhancement and depletion mode. So here you can see the construction of the N-channel MOSFET. You are having the source, drain and the gate. In that gate you can see the SiO2 and the aluminum layer. And the working of the N-channel MOSFET enhanced mode. So here the MOSFET can be worked in the enhanced mode. If we can change the polarities of the voltage, then you can find out the difference in the channels, that is when NPN or in the case of the PN transistor, there will be change in the voltages. So when you say no voltage is applied between the gate and the source, some current will be flows to the voltage between the drain and the source. So that some voltage is applied at the VGG, then the minority carriers, that is holes, gets repelled, and the majority carriers, that is electrons, gets attracted between the SiO2. The same amount of this positive terminal, that is a certain amount of this drain current will all flows from the source to the drain. When this positive potential is further increased, this current is increased due to the flow of the electrons from the source, and then it is pushed due to the voltage. Hence more current is formed and it is enhanced due to the increase in the electron, and that's why we call that as enhanced mode MOSFET. So you can see the diagram of this N-channel enhancement mode MOSFET. And in the case of the depletion mode, there will not be any PN junction layers between the gate and the channel, and also there will be the silicon layer and the material aluminum layer which is placed in between the parallel plate capacitor. They works as a depletion mode, and the gate terminal will act as a negative potential and the drain will be act as a positive potential. When we do not apply any voltage through this gate and the source, some current will be flows due to the voltage between the drain and the source. That voltage is here negative, and that negative is applied to the VGG voltage. Since this is the negative voltage, this is minority carriers will be created and the electrons will be repelled and the holes will be get attracted. So with some amount of the negative potential, certain amount of the drain current will be flowing between the source and the drain. When this negative potential is further increased, the electrons gets depleted and the current will also get decreases. Hence this is called as depletion mode MOSFET. And here you can see the N-channel depletion mode MOSFET. So drain characteristics, here it is between the drain current and the drain source voltage. So for different values of the gate, you can find out the drain values. some of the values will be operating in the enhanced mode and some will be in the depletion mode. So you can see the transfer characteristics here. This is also defined as the change in the variation of drain source voltage with the change in the drain current and gate source voltage in both the depletion as well as the enhancement modes. Thank you.